everyone, welcome to Deeksha Vedantu. I'm your Aditi Mam, and today beta in this video we are going to quickly dive into the atom and look at all the scientists, all the theories that significantly impacted what we study today, the actual structure of atom. From where it started, who gave the first theory, all the postulates, all the rules, all the experiments to what the today's structure that we study of atom. Okay, now this whole sequence, this whole lineage is very important of all the scientists, so make sure you watch this video till the end with full attention over here. Okay, and for that subscribe the channel and let's dive straight into it. Now beta, the first person to ever tell anything about atom was our Dalton G. Okay, now Dalton G came and he said that atom is indivisible. It cannot be broken into smaller pieces. It is the smallest unit to ever exist, and all of us, you, me, this pen, this board, every literally thing is made up of atom, and this is the smallest unit, right? Now during this theory, Dalton G said normally that it's the first experimental description. Okay, it is an experimental based description of the matter, that all matters are tiny and particles are called atoms, the fundamental building block that cannot be broken down. And this theory, Dalton G, became the starting point of all the experiments, of all the upcoming theories, of all the upcoming experiments done on the atom and the atomic structure that we studied today. Okay, now some of the questions that arised because of what Dalton G said, that what are atoms made up of? Okay, I can see that it's the smallest unit, but it has to be something. The name, it has to be something, right? So what would they look like if we see them? What makes atoms of one element differ from other? How my atoms are different from yours? Because we definitely don't look alive, right? So what are atoms? If they are indivisible, then everything should look same, literally, right? Then came beta J.J. Thomson, the second most important person, and he said that actually, okay, before that, let's study one thing. Now, J.J. Thomson was doing some experiment with some gases. Okay, now he was having a gas and he was trying to pass electric current with the help of cathode, which is negative charge, anode, which is positive charge, and he saw that the electric rays, they are going from positive and they are going from negative end to positive end. And he was like, why is that the case? Why are they not traveling from positive to negative? And then he discovered they are traveling from negative to positive because of electrons. Electrons will be repelled by negative charge and will be attracted by positive charge. So they go from negative end to the positive end, but these rays were called by him as cathode rays. Okay, so he called them cathode rays. They are traveling from cathode to anode. Then he did all his experiments with electric field, with magnetic field, and he got the same thing, that these are negatively charged particles. And a very important thing he figured out from this, that the mass of these charged particles are lesser than atom, and hence he deduced from this that these mass is lesser than, the mass of these charges are lesser than atom, and hence as atom is the smallest unit as a whole, but it is made up of another thing. It has one more thing inside it, that is your electron. Electrons resides inside these atoms. About this experiment, he said that these charges, these electrons are independent of the gas we have taken in it. The charges, these rods, the cathodes and anodes he take, these are independent of the material of these rods. Okay, and these electrons are present in every atom. What is the charge of electron? 1.6 10 raised to power minus 19 coulomb. You have to remember this by your heart. You have to remember this by your heart, everyone. Okay, now this is the basic idea what J.J. Thomson gave. But then everybody asked, if atom is there, okay, then in atom we have electrons, but then electrons are negatively charged, then atom should be negatively charged. okay, but I am not negatively charged. I am not running towards a node every time I see a node. Okay, I am made up of atoms. If atom is negatively charged, I should be running towards a node, right? But that's not the case. Then he suggested that there is also positive charge inside the atom, because atom as a whole is neutral, right? Atom as a whole is neutral. So if there are electrons in it, there should be some positive charge in it. Okay, sir. Okay, but where is it? So he said, he gave this plum model, this watermelon model, that he said that positive charge is scattered. It is uniformly scattered just like the red pulp, and inside that, just like these seeds, we have electrons. So these are seeds, these are what? Electrons. This whole pulp are what? The positive charge. Right? That's what his theory is, that atoms are electrically neutral. So where is the positive charge? So Thomson said that atom is a sphere of positive charge with electrons embedded throughout it. Okay, Thomson, he gave the red pulp as positive charge, seeds as electrons. First genuine attempt to balance the positive and negative charge inside the atom. Okay, now here till we have agreed, like, okay, now we have pretty much all the answers, the atoms and all those things. Atoms is neutral, so it has positive and negative charge. Negative charge is electrons. What is the positive charge? What exactly is happening? How are they inside? Is this true or not? So then came Ernst Rutherford. Right now, beta, under Rutherford, there were two people who were doing their PhD under Rutherford. His students was Geiger and Marsden. Right, so they were doing an experiment in which they threw alpha particle. Alpha particle is a positively charged particle. They threw it at the very thin golden foil, very thin gold foil. Okay, so it has one atom, that much thin it is. Okay, so what they saw is, they saw that when alpha particle is going towards them, almost maximum of them pass through the atom. Okay, then they see that some of them are little bit deflected, and some of them quite literally bounced back. Almost to an angle of, see, this is complete an angle of 180 degree, right? So they bounced back to the angle of 160 degree, 150 degrees. What does that mean? And when they saw that they are bouncing back. This is the atom, and they were bouncing back at an almost 180 degree angle right at the center. The atoms the alpha particles which went a little far from this center did not deflect, did not bounce back at this big angle. They were small. They went like this, or some even passed straight. So what is actually happening? Then they deduced from this that this is a positively charged particle. If it is bouncing back, that means it is being repelled by something that is also a positively charged particle. It should be a positively charged particle. If it was negative, it will be attracted, right? So what were the things we concluded from this? This was concluded that, where was it? Okay, yes, it was concluded that, see, positive charge is not spread out. First thing that Thomson said, they proved it wrong. That positive charge is not spread out. If it was, all the alpha particles would have bounced back because of the repulsion, right? But they were not, right? It's concentrated in a tiny dense center, that is your nucleus. That they said from the center, at the center only it was bouncing back. So at the center there is a very, very high positive charge which is repelling our alpha particle, and it is concentrated in a very tiny space, that is called the nucleus. That is called your nucleus. Okay, and we studied most of the atom is empty. Why? Because most of the alpha particles went straight. Because they were not interacted with electron or with positive, because maximum amount in the atom is an empty space. Okay, so second was that. Then we have nucleus. Okay, what is nucleus? It's a very dense and holds all the positive charge and most of the mass. Nucleus holds most of the positive charge and mass in the atom, right? Then electrons revolve around the nucleus. That is a very important observation he gave, that electrons actually are revolving around the nucleus like a planet, like our planet is revolving around the sun. right? And just to give you a measure, this whole atom is, let's say, a cricket ground, and a grain of pepper, a literal small grain of pepper is your nucleus. That's how nucleus is in comparison to your atom. Okay, so what actually Rutherford said? Rutherford said that he gave the first model to propose a central and a massive nucleus that was positively charged, right? Explained the behavior of positively charged alpha particles in the gold foil experiment. True. Then he gave, according to this theory, you have to write this. This is the introduction of Rutherford. They will ask you about the gold foil experiment and Rutherford postulates. So in the introduction, you have to write this paragraph. According to this theory, atoms have a nucleus with a positive charge and most of the mass surrounded by electrons that orbit like planets. Understood? It is a atom with most of the mass at the center, most of the positive charge at the center, and electrons are revolving around just like planets are revolving around the sun, right? It explains why particles can pass through or bounce off atoms and is the basis of our current understanding of atomic structure. And then you have to write all these postulates. Postulates were, most of them passed straight, some of them got deflected, some of them bounced back at almost 180-170 degree angles, depicting that all the positive charge is residing at the center of the atom. Most of the atom has empty space and electrons are revolving around the atom in an orbit. Understood? Understood? Okay, so this was your second theory. So first came Dalton, second came Thomson G, third came Rutherford. First came Dalton. He said indivisible ball. Thomson gave positive charge, just like the red pulp of watermelon and seeds are like electrons. Then Rutherford came and he did the gold foil experiment. From there he gave certain postulates and said and gave us a nuclear model, because he gave us a nucleus, right? Then came Bohr. Now what was left? Why there needed to be an improvement in Rutherford? He pretty much explained everything, right? But actually beta, he could not explain certain things. And one of the things were, when we studied describing motion, right, in the physics chapter, we studied that something that is rotating is continuously accelerating because its direction is continuously changing when it is rotating in a circle, right? So as it is accelerating, it should lose energy, and as it is losing energy, the radius will get smaller and smaller and smaller, and the electron will fall into the nucleus, right? The electron will eventually fall into the nucleus. It will rotate and will keep on losing energy and will fall into the nucleus, and the atom will collapse. Boom, the atom does not exist anymore. You and I won't exist anymore then, but we are. That means atom does not collapse. That means atom is stable. But how is it stable? That's where Bohr G came, okay? But atoms are stable, so the model was incomplete. A new idea was needed. Okay, now Rutherford did one more thing. He discovered the positive charge. When Thomson came, he said that positive charge is the red pulp, right? And it's distributed inside the atom. But we know that now positive charge is not the pulp, it's just concentrated charge at the center, that is called nucleus. But why is that? What is that positive charge? So Rutherford named it as proton. Right? So nucleus positive charge comes from proton, much heavier than electrons. One thing you have to remember, the mass of proton is very, very heavier than mass of electron. However, the charge of proton, charge is represented by Q, okay? So the charge of proton is equal to the charge of electron. The only difference is electron is negative in nature, proton is positive in nature. Then charge is same, but mass is very heavy, right? And it has equal and opposite charge. For a neutral atom, now my atom is neutral. It is not positively charged or negatively charged. So the amount of negative charge should be equal to the amount of positive charge. Basic common sense, right? So that was the one thing he gave. That means in helium, if we have 2 protons, we will have 2 electrons. In sodium, if we have 11 protons, we have 11 electrons. Until this It is clear. Now we have to give the answer to one more question, why the atom does not collapse. Then Bohr ji came and he said, actually electron is not just rotating around the nucleus, it is rotating around the nucleus in a fixed circular path. In a fixed circular path which has fixed energy, and it cannot change its circular path. It cannot change, it cannot shift to another circle, it cannot shift to another energy, right? So he said electron revolves only in fixed circular paths. These are called shells, orbits or energy levels. We named them K, L, M, N. K is the nearest to the nucleus, and then we go by L, M, N. As we go above beta, energy rises. K has very less energy but it is stable. L has more energy, less stable. M has even more energy, even less stable, and has more energy but less stable. Okay, you will study about the stability. For now, let's remember the energy. As we go out, energy rises. Energy, the electron have some energy, and that energy rises as we move towards. So the electron in this orbit has more energy than electron is in this orbit. Done? Understood? Okay. So for K, N equals to 1, and then for L, N equals to 2, number of orbit. What? First orbit, second orbit, third orbit, fourth orbit. K, L, M, N. Understood? In a fixed shell, an electron does not lose energy. See, very important. In a fixed shell, electron does not lose energy. That's the main point that Rutherford could not explain, right? Then rather have a definite amount of energy. They have a definite amount of energy, and that's why it's called stationary state. Stationary means not changing, not moving, right? This stationary state explains the atom's stability, and hence it was explained that since electron is not losing energy, it will not fall into the nucleus, and hence the atom will not collapse. Okay. However, I said that it cannot shift its orbit, right? The electron which is rotating in K shell cannot move to L shell. Because, why beta? Because energy is more, right? We said that energy increases. So energy of L shell is more than energy of K shell. Right? Electron revolving in K shell has less energy than electron revolving in L shell. So if this electron gains energy, it gets energy from somewhere, and the energy is now equal to L shell, the energy of L shell, then it can move to L shell. Okay, it's just a criteria. You should have this much energy to enter my home. So L says this, okay, and then the electron in K says, okay, let me get some energy. He gets some energy and move to L shell. And now K has less energy, L has more energy. Now electron wants to move back to K. So it will lose some energy, right? It will radiate some energy and out. Energy is less, move back to K shell. That's what exactly it's. It jumps shells only by absorbing or releasing a fixed packet of energy. Done. That's the main postulate, that's the main thing about Bohr beta, and let's study something a little bit more. Now this exactly explained our atomic structure with precision, okay, and there is something called atomic spectra, will you study in later classes, and it introduced the concept of quantized energy levels. Quantized energy level means that the N for this K can be equal to 1, it cannot be equal to 1.5, 1.25, 1.35, that it cannot be equal to decimal values, cannot be equal to 1.25, 1.5, it cannot have that energy. The energy will always be quantized, a proper number, a fixed number, okay, more like a fixed number, okay, it cannot change. Now why are these called KLMN? It's written here, you can learn that. And some of the exceptions that Bohr gave was it was only applicable for hydrogen atom. That means the atom that has only one electron, only applicable to that. So that's a tricky part, okay. Then could not account for the behavior of multi-electron atoms. If there are one or more atoms than one, then the behavior of those atoms were different than what Bohr described, right, and didn't incorporate the wave-like nature of electrons. Here we are just studying that one electron is revolving. We are not saying it is maybe behaving as wave. What exactly is happening? So that is a topic for your +1 classes beta, okay. Till here, this is enough. Okay, now one more thing you have to learn before we end this session is neutron. Now beta, James Chadwick ji came. We studied about, let's go through this first. We studied about Dalton, indivisible ball, Thomson, watermelon model, like, right, pulp is positive, seeds are electrons. Then came Rutherford. He just said that nucleus at the center, positive charge, concentrated at a tiny space, electrons are revolving around. But the question arises, why these electrons are not collapsing inside the atoms as they are accelerating and they are losing energy? So Bohr ji said they are revolving in fixed orbits. They are revolving in fixed orbits with specific energy. These are called orbits, shells, energy levels, and they cannot change these orbits, and hence they cannot collapse in the nucleus. And after that we studied about limitations, right? We studied about limitations. So after that a modern theory also came, which you will study in +1. Until now this is what you have to study. And beta, we are still discovering atoms, right? There are so many much more things inside these atoms that you have no idea of, and I don't want you to have that idea right now because it's too confusing. Okay, that's a part if you choose to study in your graduation, in your post graduation. Okay, last thing beta was your neutron. Then James Chadwick ji came. He saw one thing, that what is happening, that in hydrogen we have one neutron, one proton and one electron, right? But in that means there is one proton, and in helium there is two proton, right? See, you have hydrogen, you have helium. It has one proton, one electron. This has two proton, two electron. Now the mass of electron is very less, so we don't take it when we are counting the mass of an atom, right? So we are counting the mass of proton. Then according to that, the mass of helium should be simply 2 times the mass of hydrogen, right? Because it has only one proton, multiply by 2, that is 2 protons, right? Makes sense. But when we discovered, we saw that it's not 2 times, it's actually 4 times. So what is happening? Where is the extra mass coming from? Then we saw that there is one more thing inside the nucleus, not just proton, we have neutrons. We have neutrons inside this nucleus beta, and the mass of neutron is equal to the mass of proton. The mass of neutron is equal to the mass of proton, but the charge of neutron is simply not zero, it has no charge, it is neutral. So it is giving the mass to an atom, but it does not giving any charge to any atom, right? So inside the atom, now we have a nucleus where we have proton now as well as neutron. And outside electrons are revolving, right? Now the charge of this electron is equal to the charge of this proton, equal and opposite. This is negatively charged, proton is positively charged. But inside the nucleus we have proton, with that we have neutrons also. Neutrons have mass equal to protons, but they have no charge. So they add weight into the atom, but they do not add any charge into the atom. Understood? That's what basic neutron is, and neutrons sit in the nucleus of all atoms except hydrogen. That you have to remember. Hydrogen beta does not have a neutron. That's why its mass is given by only just one proton. Okay, now atom's mass is equal to proton plus neutron. Now the actual mass of the atom will not be given by just proton, it is also given by 2 neutrons as well. So now mass is 2 proton plus 2 neutron, 4 times the 1 proton. Understood? Then beta we have electrons mass is negligible because we don't take that. Now like charges should repel, neutrons space protons. Now one more thing people ask, that there is protons inside the nucleus and all are positively charged and it's very small. We saw cricket ground and one pepper, right? So how is so many positive charges are not repelling inside that small space inside the nucleus? That's where neutrons come into the play. They arrange themselves inside 2 protons and not letting them repel each other, and they make into account one more very beautiful force, that is your nuclear force. Nuclear force bacha, it is charge independent. It is charge independent. So it is acted between two protons, two neutrons, neutron, proton as well, and it acts as a very small space. That is why it is called nuclear force, because nucleus is also very small. So neutrons actually help to maintain the repulsion between two protons. Done. That is the whole atomic structure. That is the whole atomic theory, beta. So these are the points. Just remember this thing, okay? Dalton, Thomson, Rutherford and Bohr. Dalton, Thomson, Rutherford, Bohr. Dalton, indivisible. Thomson, pulp, red pulp, positive, seeds are electrons. Rutherford came that electrons are revolving around the nucleus, charge is at the center, but could not explain why atom is collapsing. And then Bohr came, and Bohr said that they are revolving in a fixed orbit. James Chadwick G gave the concept of neutron, J.J. Thomson gave the concept of electron, and Rutherford gave the concept of proton. And protons and nucleus together in a nucleus are called, that you comment down below, and I will see who stayed till the end, right? Because you will be 95% ahead of your peers if you stay till the end. And comment down what are neutrons plus protons inside the nucleus together called. That is it for this video. This is a very important, bacha, you can get this for 5 marks straight, okay? So make sure you revise this again and again, you come back to it, and that's it for this video. I'll meet you in the next one. Tata, bye bye.